All right, so these are distance equals rate times time problem. You remember those? We have done these types of problems before, earlier in the year. Those of you in physics classes, you've been doing these types of problems as well. We do a lot of arrow drawing, right? So if they're going in opposite directions, we draw arrows in opposite directions. If it's an out and back, we draw those arrows. Now normally arrows represent the distance, correct? In the problems today, we're not going to be drawing arrows that represent a distance. We might draw arrows just to represent what's going on in the word problem. But in our work today, we're not going to be talking about the distance. We're going to be talking about the time. And so we need to solve this formula here for time. What would you do to both sides of the equation here, of the formula, to solve it for time? Divide by r. You got it. So if you divide both sides by r, you get that time is equal to the distance divided by rate, or how fast something's going. We are going to be using that formula now for our problems today. So the problems today, they're going to tell us information about the distances each time. The distance isn't going to be a question. The distance is going to be one of the given information. And then the rates are going to be different, right? And then the times are going to be different, but we're going to be doing stuff to compare the times. Sometimes the times will be added together, and like they would say the total time, the total round trip time was a certain number. Sometimes they might say the times compared to each other, like one, like it was shorter amount of time going as it was coming back. Or it might say the two times were the same time, where we would set things equal to each other. And so we just have to be able to read those problems and know what's happening. So the first type of example I'd like to show you is, let's just draw this out. There's a guy that wants to go on vacation. We'll call him Trey. Trey really wants to go on vacation. We're going to use your name, Trey. Trey wants to go to the beach, because beaches are cool. So here's the beach. Here's the waves. They're really bad waves, but that's where it is. And this beach is 504 kilometers away. Now, have any of you ever gone on vacation, like driven somewhere that you were excited about going? You always seem like you drive faster when you're going there. And then when you're coming back, it's like you're not really excited about coming home, so you're not in a big hurry. So that's what happened here. They drove faster going to the beach than what they did coming back. So this was a faster way going. On the way back, the same 504 kilometers, they were slower. Now, how much faster were they? They were 14 kilometers per hour faster. So right now you have a choice. We have to decide which one gets the R, right? Which one just gets the R and which one gets the other, expression compared to it. Personally, I like to pick the slower of the two and let that one be just the one unknown, and let the faster one be R plus 14. Personally, I like that because I feel like we make less mistakes when we're adding than when we're subtracting. So which one is the slower? The one going to the beach or the one coming to the house? Coming back to the house. So I would say that this is R. That's our speed, right? That's our rate that we're going. So going there, if we were going 14 kilometers per hour faster, what would you say would be the rate that we were going to the beach? Does that make sense? It's R plus 14? Yes? That was just part of the problem. I told you we were going 14 kilometers per hour faster. Yeah. I didn't write out the whole problem because it's kind of a long problem. It would take us a long time to write it all out. So I'm just kind of feeding it to you as we go. So right now we have our distance is 504 and we have our rates. We have our speeds, right? Do we have enough now to write an expression to represent time? Isn't time distance over rate? Yeah? So we actually do have enough to show what our time would be. Distance divided by rate. But before we go there, I've got a question for you. I know that I'm going faster to the beach and slower coming back home. Which way am I spending more time in the car? I'm spending more time in the car when I'm driving slower back home. That's really important that you understand that concept. Because sometimes you think when you're going faster, that means it's also more time. You know, like a higher rate might mean a higher amount of time. I know it seems weird to say that now because you're like, clearly it wouldn't be. You know, if you're going faster, that's going to be a less amount of time. But when you start writing out these equations, sometimes that gets mixed up. So just be aware of that. And so you might want to write that this is more time, right? That the slower you're driving, the more time you're spending in the car. And this is less time that you're spending in the car. Now the last fact that they tell you in this problem, which I'm going to let you know right now, is they tell you that the total amount of time in the car, your total drive time, was 21 hours. Okay. So let's see if this makes sense. If we write out our verbal model, we would have our time going to the beach, right? Which is our less time, right? The time to the beach plus the time home, right? Has to equal 21 hours. Does that make sense? All right. Time to the beach. Tell me how I could write that as an expression. D divided by R. What's the D? 504. What's the rate going to the beach? R plus 14, right? Because we don't know what anything else is. We just know it's R plus 14. Everybody with me there so far? Okay, coming home. What's my distance? 504. And what is my speed or my rate? R. And that has to equal 21. That's the setup for this problem. I don't think that would have been a natural thing for all of us to come up with right away. So that's why I wanted to take the time to really go through how we would do that. Does that make sense? Now, how would I solve this? Least common denominator? All right. So can I factor R plus 14? Nope. So that is a factor. Can I factor R? No. So what's going to be my least common denominator? R times R plus 14. So we write that by each one of our terms. Now some of you aren't doing that. Some of you are like, I don't need to do that. This is easy. And those of you who aren't doing it are pretty much forgetting about the 21 over there, and you're just writing equals 21. And then you're missing the problem. Everything gets multiplied by the least common denominator. You're going to want a calculator today for sure. 504R plus, let's see, here R is simplified. 504R, 504 times 14. 756? 7,056. Thank you. Equals, all right, 21r times r plus 14. That's 21r squared. All right, 21 times 14. 294. So 294r. That looks like fun. Yeah? That's not a big deal. It's a quadratic, right? On r squared's to the right of our equal sign, so we should move all of our terms to the right side where the r squared term is already positive. So we're going to move everything to the right side. There's going to have a 0 on the left. I've got 21r squared. All right, let's figure out our r term. Everybody take out your calculator. Start with 294. And we need to take away 504 and then take away 504 again. Or you could just take away 1008. Doesn't matter. I know it's going to be negative. 714. Thank you. Minus 714r. And then we move our 7,056 to the other side. And let's hope that 21 is a common factor, right? Because who wants to do AC method with those big numbers? Not me. So let's see if 21 goes into both 714 and 7,056. Do they?
Yeah.
Oh, good. We're going to factor out a 21, make our life easy. Well, easier anyway. All right. What do we have? 34 minus 336. All right, so now we just need to come up with a couple numbers that will multiply to negative 336 and add to negative 34. No problem, right? Well, this is when we use our calculators, right? We just start trying different numbers. We know the signs are going to be different, and they need to have a difference of 34. And so you start trying different numbers on your calculator. Start with 336, right? Maybe divide by 2. Those are going to be too far apart. Maybe divide by 4. Still too far apart. Maybe divide by 6. Keep trying. You found one. You found a couple that worked? 42 and 8? Negative 42 and positive 8? So it's just guessing and checking. R minus 42 and R plus 8. So we're ready to solve. And we set each factor that has an R with it equal to 0. We don't set 21 equal to 0. Why not? It doesn't have an R, and 21 is not equal to 0. So we don't want to set 21 equal to 0, because we know that's not true. Okay, so R ahead there has to be 42, or R is equal to negative 8. Well, are we going negative 8? No, because then we'd end up in the ocean on our way home. That wouldn't work. What is R? What does that mean? That's the rate where? Coming back home. What's the unit of measurement? Kilometers per hour. So this was 42 kilometers per hour. And what was our rate going to the beach? 56. Good. So they do take some time to solve, don't they? So in today's work, your job is not going to be to do all the solving. We're actually going to save that for tomorrow. Today I want you to focus on just setting up the problem. Because that's the understanding part. That's the new stuff for today. Knowing that you can set up the problem. And then tomorrow we'll take the time to solve. Make sense? Maybe? Awesome.